Okay, this is where we start tying in the idea of a limit. Same graph, same equation, same everything that we had in example one. Okay, so this time it's wanting us to use pre-calculus notation to be able to write calculus notation and perhaps answer the question. Okay, so here we go. On the very first one, we got our graph. We have information from above if we need. All right, so let's get drawing. Okay, all right, so here we go. As x approaches negative infinity, so as x goes to the left, as the graph goes to the left, what does the graph of f of x do? All right, well, so in other words, what does the y do? Well, this is what this asymptote's about, right? So as I travel to the left, that's what this is saying. As you travel to the left, okay, what do your y's do? Well, my y's approach this asymptote, so that is a flat out 3. Now it's never going to be 3 because it's never going to cross that asymptote, but it's getting close to 3. That's what this arrow means. We're getting close to 3. As you get close to negative infinity, or whatever that means, your y's, as your x gets close to negative infinity, your y's go to 3. True? Let's write that in calculus form, limit notation. So the limit of f of x as x approaches negative infinity equals 3. So, okay, so this idea of a limit where it's not ever was 3 is what this is the answer to. The answer to it is 3. Okay, but you're like, I'm never at 3. That's right. That's what the limit's saying. The limit is saying as you get close to negative infinity, or you try to approach negative infinity, what is this approaching? Okay, so that limit allows you to say an exact amount. That's very powerful. Okay, as x goes to the right, as we travel to the right, what does the function approach? What do the y values approach? It's the same thing. This time we're approaching the asymptote from below. So once again, it's 3. All right, and here we go. The limit. I'm going to write it this way first this time. As x approaches, and this would explain why some people read it this way, infinity of f of x is also 3. But it's approaching from a different direction, right? Over here, we approached it from the top. As we're traveling this way, as we go to the left, our y values are getting close to x from above. And over here, my y values are approaching from below. Okay? All right, here we go. As x approaches negative 3 from the right, the graph of f of x approaches what? Okay? So as I'm heading to negative 3, oh my gosh, from the right, well, the right's over here. Okay, so I'm coming from that direction. That's where I'm traveling from. I'm traveling from the right, and I'm heading to negative 3. Man, I'm going through the floor. That's what this asymptote is. That asymptote's telling you you're heading to negative infinity from the right. I'm not even looking over here yet. That'll be in a second, I'm sure. All right, so heading this direction from the right, where are we going? We're going through the floor. Okay, so this would be negative infinity. We're heading down forever. All right, so here we go. You ready? The limit as x. Oh gosh, that's too big. That's too big. Sorry. This is supposed to be a subscript. Okay, it's a little bitty. As x approaches negative 3 from the right. Okay, so a little plus sign there of f of x is negative infinity. It's going down. It's going down. You can say it. You can say it's negative infinity. Right? You could argue it doesn't exist because it's not actually heading to a number that we know, but it's okay to say negative infinity. All right, you know what's happening next? As we approach 3 from the left, that's over here. So we're traveling this direction on the curve, coming from the left, I'm coming from the left, and I'm heading towards x equals negative 3. Where are we going? Through the roof. Through the roof, positive infinity. All right, let's write it with limit notation. The limit as x approaches. Oh, 3. I'm doing the wrong thing. Oh my gosh, I messed up. All right, sorry. Not negative 3, 3. I was expecting a negative 3, so sorry, but that's okay. Hey, all right, there's a hole there. All right. but we know where the hole is. All right, we said that before. The hole was at 5/3, right? We said that in the previous example. So, all right, so as I'm approaching 3, not -3, sorry about that. I'm sure we'll do that in a second. From the left, we're heading to 5/3. We never get to 5/3. 5/3, there's a hole, but that's not what matters. It's asking, what are we approaching? What are we approaching? That's the important thing to keep in mind here, guys. So the limit as x approaches 3 from the left, and we're heading from the left, coming from the left, or man, we never get to 5/3. There's a hole there. There's a hole in the road at that point. That's okay. It's a small one. It won't mess up your car. That's 5/3. All right. Aha, here's what I was expecting. -3 from the left. I see what's happening. These are all lined up. Okay. So -3 from the left is over here. Coming from the left, heading to -3. Where are we going? We're going up, 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 up. Never stopping. Never stopping. So this is positive infinity. That's what I thought the other one was, but they put them right above each other. So the limit as x approaches -3, this time from the left, of f of x is infinity. That looks bad. Boo, 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 boo. All right, is infinity. All right, what about here? As I'm approaching 3 from the right, well, it's heading to the same hole, right? Same place that we don't even know is not there because we're driving, right? So, all right, so let's, it's the exact same value as before. It's exactly where the hole was, 5/3. All right, how do you write it? You write the limit as x approaches 3 from the right, and our function that we're using, of course, is f of x, is also 5/3. Same answer as the one directly above. Okay. This side had 2 different answers coming from the left to the right, and that's kind of explained by the graph. Coming from the left, coming from the left, you're going up. Coming from the right, you're going down. Those aren't the same. But on this one, coming from the left and coming from the right, we're going to the same point that does not exist. Can you explain what the value of a limit represents in terms of the graph? Yeah. All right. The value of a limit represents the y value that the graph is approaching as x approaches whatever they're asking you to approach. Okay. So the value of a limit represents the y value of the function as x approaches a certain value. Thank you and have a great afternoon. That's pretty good. Yeah, the y value. So anytime you answer a limit question, you are answering what the y value is. That's very, very important. Okay. Informally, a limit is a y value which a function approaches x of some value. That's what I just said. All right. So here we go. The limit f of x as x approaches c equals L means x approaches c. As x approaches c, f of x approaches the y value L. That is wonderful. That is wonderful. So not really sure what we were supposed to put there. Other than that, I'm pretty happy with that. All right, let's move on.